Hello and welcome to the webinar on how to repair your aircraft skin panel using cold spray. We're glad you joined us. Today we have Jared Shell from Mid-America Aerotech, and he's going to talk to us today about skin panels in the aerospace industry and how to repair them using cold spray. Jared, thank you.
All right, thanks, Rob. Uh, Today, we're going to talk for the next 15 minutes, very brief 15 minutes, and talk about cold spray repair using on skin panels for aircraft components. We'll be briefing this cold spray technology itself and how we can effectively and safely repair many aviation components using this method. We'll take a look at one specific repair on B1 that we wrote and managed for the Air Force and how that repair method can be brought over into the commercial aerospace world. You'll learn a little bit about my company, Mid-America Aerotech, and how we can increase your ROI, improve turn times, and help out with all of your maintenance needs out in the aerospace maintenance world. So let's see. Like Rob said, my name's Jared Shell. I'm a husband, father, mechanical engineer, aspiring musician, better in my younger days, but recently certificated pilot, and I do some business development efforts here down in our shop at Mid-America Aerotech. For the last about 10 years, 11 years, I've been involved in cold spray aerospace commercialization. Back in 2007, a couple years before that, myself and a few of my colleagues were hired on to do research and development for the Department of Defense, looking at new advanced manufacturing methods, one of which was cold spray. And in 2011, our crew was picked up by a larger organization to commercialize cold spray for the aerospace sector. We did everything from cleaning the shops and sweeping the floors to going on international business development trips and everything in between. Data generation, being a lab rat. In the process, we got our FAA repairman certificate, so actually pulled the trigger on a number of the repairs that we were writing and working through the approvals with. In 2018, I started doing business development. Less out of the strict engineering role and out into the customer relationship kind of world. But I continue to work on applications development for our organization here in the West Fargo facility. So enough about me. Let's get into the actual aircraft skin panels. So aircraft skin panels is a broad topic, a very broad topic, but every aircraft has some type of a skin panel on it. Main functions, they're a wonderfully engineered, wonderfully designed type of a product or a component, and they serve multiple features. Primarily, they're providing that shape and that contour, that aerodynamic contour to any number of airframes. But they also serve to aid in the pressurization functions on aircraft, as well as absorbing some of those static and dynamic, the flight and ground loads that would be encountered during an aircraft's service life. But regardless of function, these aircraft skin panels are facing the environment. Whatever they're doing, they're facing the onslaught of rain and weather phenomenon. They are constantly being exposed to things like foreign object damage, or even just the normal de-icing fluid. You know, the collection of these types of activities often result in wear and corrosion setting up on any number of aerospace components. Obviously, we're talking about skin panels today, but they're out in service, they're working, and as a function of that service life are exposed to this wear and corrosion. Now, about skin panels, many of them are firmly, riveted in place. They're not really removable per se. They only get inspected once the airplane comes in or the helicopter comes in for phase checks. But on some panels, these are replaceable and removable. But regardless of the wear or the corrosion that might set up on these things, there exists opportunity for loss. Now, in the commercial world, we're talking about revenue generation, taking that airframe offline and making it unavailable due to the maintenance cycles for revenue generation. On the military side, we're talking about warfighter readiness. Having that weapon system unavailable for any number of reasons affects our ability to go and do functions out in the Department of Defense world. So regardless, it's these maintenance cycles have a tremendous cost to them. So we're going to dive right into one specific example, and this was a skin panel repair that we had built and managed a little bit for the U.S. Air Force on Rockwell B-1B Lancer, the Bone, and its FEB panels, forward equipment bay panels. These so the B1, on the nose of B1, you've got equipment bays, right? And you've got panels right here that cover up those equipment bays. So creatively, those are named forward equipment bay panels. Now these panels are meant to be removable. They are held on by fasteners, right? These panels are aluminum alloy, lightweight, very strong design, but the fasteners that hold them on are a harder material. And because of the repeated installation and removal of the panels and the fasteners that keep the panels on, these harder fasteners wear against the softer aluminum. So over time, this accumulated wear can lead to the growth of these fastener holes up and past a point where they exceed their critical values, they exceed their service limits, and a repair needs to be addressed. Now, this is very, very common in industry, especially in aviation maintenance. You have service limits that are set, and a component exceeds that service limit. Once that service limit is reached, that component either needs to be repaired or replaced. Now, in the terms of these skin panels, on B1, it was a very, very expensive component. The other thing about these panels, these FEB panels, is that they are match drilled. It means that they only fit on one specific airframe. You can't pull one off of serial number 1 and put it on serial number 2. The holes don't line up. And so there's also a very long timeline to get replacement components like this made. So if only there were some method, that we could call on to do some sort of repair over and above and improve against the standard repair methods. And let's see how tech savvy we can get. Yeah, there it is. Cold spray. Enter cold spray. Okay, everybody's having fun, right? So cold spray, what is cold spray? Many people on this webinar probably have a topical understanding of cold spray, if not a deep dive understanding of cold spray. But there's also people scratching the surface. So we're going to start right at the top and just do a brief couple minutes of what is cold spray. Simply put, we take powdered metal and blow it through a very specially designed tube, nozzle, straw, whatever you want to say. When we do this and we accelerate these powder particles through the nozzle, they get going Mach 2, Mach 3, and when they hit a substrate, they plastically deform. And that plastic deformation allows that powder particle to stick onto a substrate, and all these particles build up, and you end up with a really nice deposit. It's a solid state process, meaning we're not melting the feedstock at any point. They're very, very high strength, high density coatings or deposits. I don't even call them a coating, it's a deposit. Many of the options that we have available the material properties approach that of wrought material. Adhesion strengths, our low baseline is about 10,000 PSI, and that's just because that's the strongest glue that we can find to do our qualification tests. I think there's plenty of literature out in the industry too that shows the actual adhesion strengths of many of these deposits can be 20, 25, even more thousand PSI. So very, very useful, strong, durable coatings. Okay, so what does all this look like in actuality? Here's a very simple graphic of every step of the process. Every step of the process. We take a worn element. In the case of these FEB panels, the actual holes are oversized, maybe they're oblong, maybe they've just grown, they're the right size and position, but they've grown past a certain dimension. Well, we'll clean it up, expose some fresh substrate, and do a preparation step, and that can vary depending on the spray that we're using and the substrate that we're spraying onto. But We'll point the gun at the area of deposit, or the area that we want the deposit to be on. We'll make that deposit, and then after the deposit is up to a sufficient thickness, we can immediately take it out of the booth and go blend it. Just mechanically abrade some of that material away and make it flush with the surrounding surfaces, and then go back and replace that feature, that hole position, complete with the original chamfer dimensions and whatnot. So we like to make it look easy. That's our job, to make it look easy. It can be very difficult and very technically oriented, and there's a lot of craftsmanship that does go into it. But the steps are the same. I just showed a little bit about the skin panels. Here's a few steps, the same steps rather, on a gearbox, or two different gearboxes. Sometimes all it takes is a spray and a blend, and other times it takes a full reverse engineering element on critical elements of a particular component, geometry that needs to be restored in a very specific manner. So imagine now if you had access. Here's the pitchy part, right? Imagine now you had access to repair and restore these components that are lost to wear and corrosion. You could stretch your maintenance budgets and at the same time have access to industry expertise. That's us. Yeah. Mid-America Aerotech. We are aerospace cold spray experts. We operate a repair station, a Part 145 repair station in West Fargo, North Dakota, where we have our EASA certificate, dual AS 9100D and 9110C certificates. And I say our technicians and engineers are among the best in the world. And we have stiff competition out there. I know that my guys can handle anything that industry can throw at them. We do live in this world of aviation maintenance. We have dabbled and continue to support our academic and commercial research clients, as well as pretty much every step along the way. Everything from prototyping and repair development through first article and low rate production, and all the way scaling up to full scale production. What are we asking for? So you're at this webinar. We've learned a little bit about skin panels, how cold spray can be used to repair these skin panels. So what are we looking for? We're looking for customers, partners, industry partners who either have corroded and worn assets that, hey, maybe cold spray looks like something that we can use to repair and restore this hardware. Single units, so hard to find, hard to acquire hardware. Think about like warbird restoration, a high value in keeping that exact serial number all the way through the manufacturing and repair process. Or diminishing materials or manufacturing sources items, things that have been out in industry for a long time, and we've lost some of the manufacturing capabilities on a certain set of hardware. So if you have these, if you're maintaining a fleet and you have problems with your supply chain, talk to us about figuring out how to repair these components instead of replacing them. If you are maybe you are a warehousing organization, right? And you have stock lines of parts, and you have the ability to accumulate a batch size of 5 or 10 components. You can send them our way. We can work on some cost sharing to figure out what the right balance is, and get these components repaired and available for your customers to have immediate access, to return, to expedite the turn times, and to really be able to be able to add value to your customer's operation or your operation directly. And when you partner with Mid-America, you have access to the very best expertise in the industry. Now, what we typically charge out in industry is a test and evaluation fee, a couple $100, and totally worth it. Even at $500, we bury way more cost into our test and evaluation than we ever receive in our T&E fees. And through our typical evaluation, we'll run a component or an opportunity through our viability filter, and we'll keep a small report to kind of be the seed as this product moves along through the line. Now, we're we're doing the salesman thing because this is a fantastic deal. We're dropping our test and evaluation fees down to $150. A massive deal at $500, even better at $150. All you have to do is send us an email at sales@maaero.com, and in the subject line write web_EV and send it to my attention, Jared. In addition to dropping this price to an astronomically, affordable $150, we are including that test and evaluation report, that write-up that we typically keep as an internal document. We will go and we'll go ahead and forward that back to you for your reference. So at the end of the day, at least you've got a real good look at what Cold Spray can do for your hardware. So want to be stewards of everybody's time. Time is very precious, and so I appreciate the moment that you spent with us this afternoon. We do have a little bit of time here for Q&A, and maybe if there's anybody that has any questions, go ahead and type them into the chat function, and we can go ahead and read those off. And but in the interim, I just want to say thank you. I mean, like I said, time is precious, and we appreciate even the small moment that you spend with us. If you have any questions or just want to know more about Cold Spray, you can use that same email address, sales@maaero.com, and we've got several brochures that we'd be happy to send out, or just call and have a conversation with us to see if Cold Spray could be used in your organization.
Say, Jared. We do have one question. Actually, we have a couple questions. The first one is, how do I evaluate whether my skin panel can be repaired?
How do you evaluate? Give us a call. Give us a call. I mean, there are certain features that are certain types of problems that are very, very straightforward to repair, and some are very, I would say, more complicated. And so with that first phone call, with that first evaluation, what we can do is figure out where in the spectrum does your particular part fit or fall, and then we can kind of take the next steps after we take a good look at it and give you our best approach.
Great. We got one more we have time for. Is there FAA documentation required when completing skin panel repairs?
Depends on who the customer is. For FAA governed components, absolutely. We would work with maybe you've got engineering representatives on staff, maybe you have access to contract DERs, or maybe you just have a panel that needs to be fixed. We have access to a whole slew of DERs as well that we can develop that repair specification and work with the appropriate approval function, whoever the DER is that whether it's ours, yours, or somebody else's. We would work together with that DER to ensure that all of the appropriate regulatory elements are properly addressed.
Great. And we got one last one. Scott is wondering about, can you use the aluminum Cold Spray as a structural repair on tempered parts?
So I think that's probably a loaded question, because it actually is two different questions. Can you do it? Is it possible? Is it possible? I would say the answer is absolutely, it is possible. It is possible to build up very elegant deposits that can carry load through whatever your design criteria might need. The second part of the question is, in terms of aerospace maintenance, can you get it approved? And so that's, again, we would have that continual discussion with the DERs to find out, okay, what does this area need to do? How does it need to function from an engineering perspective? And how can we engineer that deposit to serve that function and run through the appropriate ways to check and make sure that what you said happened and is actually performing that way after it's been applied.
Excellent. Well, Jared, thanks for your time. And thank you for the presentation, and thank you to everyone that turned out for the webinar. Greatly appreciated, and hope we'll be having more webinars, and so hope you can sign up for others in the future. Any last statements, Jared?
Just thank you for your time, and I hope to hear from everybody soon.
Great, thank you.
All right, thanks, Rob.